We're discovering the cosmos is full of alien planets, exoplanets, strange worlds outside our solar system.
There's much, much more out there than we had ever imagined.
We've now found over 4,000 exoplanets, a rapidly increasing array of strange alien worlds. And the more we uncover, the weirder they get.
They don't act at all like what we're seeing in our solar system. There are planets out there interacting, there are planets dive-bombing their sun, gigantic planets orbiting really close in, everything, in every kind of combination you can possibly imagine.
One alien world truly stands out. This is the planet from hell.
When we examine the atmosphere of this planet, what we find is liquid iron. The iron is heated up so much it's been vaporized, and it's falling out of the sky like rain.
WASP 76b is 640 light years away in the Pisces constellation. At first, this planet looks like nothing out of the ordinary.
WASP 76b orbits a star just like our Sun, which is really reassuring in a universe which is full of the unfamiliar.
WASP 76b is a gas giant, a bit like Jupiter in our solar system. But its location makes a big difference. Jupiter is almost 500 million miles away from the Sun. WASP 76b is just 3 million miles from its star. And that's what makes this planet a hot Jupiter. Temperatures on WASP 76b exceed 4,000 degrees Fahrenheit, creating one of the most extreme environments in the universe. The fact that it's so close to its star has another consequence. WASP 76b's spin is locked to its star.
The gravity from the star will grip onto the planet, slow its rotation over time if it had any to start with, and lock it so that one face always faces toward the star.
This gravitational grip is called tidal locking.
There are consequences for being a tidally locked planet, and not all of them are good.
That can set up some pretty extreme weather conditions. Very hot on the daytime side and extremely cold on the nighttime side.
In 2020, we took a closer look at the atmosphere between the day and night side of the planet. This twilight zone has plenty of rain, but here it rains molten iron.
Vaporized iron? Well, most materials can exist in different states, so think about water, right?
Water can be a solid when it's ice, and then when you heat it up, it becomes water, the liquid part of water, and then if you heat it up more, it becomes steam, like out of a kettle. And this is true of every chemical element. So for iron, if you heat it even more up, it becomes a gas. So you really can have clouds of iron vapor condensing and raining liquid iron.
These nightmare weather conditions are a direct result of WASP 76b's proximity to its star.
WASP 76b is so close to its star that its star is superheating its atmosphere. So the upper atmosphere is heated and rises.
The atmosphere on the day side reaches over 4,000 degrees Fahrenheit. The planet's night side is cooler at 2,730 degrees Fahrenheit. This difference in temperature sets up spectacular wind streams. On Earth, the fastest recorded winds have reached speeds in excess of 250 miles an hour. On WASP 76b, winds hit speeds in excess of 11,000 miles an hour. Strong enough to move millions of tons of iron vapor to the planet's night side, where it undergoes a dramatic change.
It's cooler there, can't be maintained as a gas, so it condenses and becomes a liquid, and then rains out.
There are clouds coming up and forming, and then rain is falling, but it's iron. It's iron vapor, it's iron rain. It would be spectacular to see in that brief moment you have before you vaporize too.
On the search for alien worlds, we've uncovered plenty of the strange, the scary, and the incredible. But we still haven't detected anything remotely like our planet. But just what are our chances of finding an Earth-like planet?
The big question, are we going to find another Earth? The answer is yes, we will. And the reason I say that is because there are a lot of planets in our galaxy. And just looking at really rough numbers, there are probably billions of planets similar to Earth. And mixing and matching all of those conditions, it seems to me that the way to bet is that some other planet, at least one, if not a lot, are going to look a lot like our own.
Finding an exoplanet with conditions suitable for life takes a lot of luck.
Sifting through these exoplanets, looking for something that's habitable for life is like an interstellar dating app.
If we have molten iron rain, that's definitely out.
You see toxic atmosphere and you swipe, and you see red giant and you swipe.
So it's like up, too hot, too cold, too small, too thick an atmosphere.
No UV rays, no, doesn't even have a star, but like it's just not working again and again and again.
When it comes to finding life, there is one basic element that everyone agrees is necessary.
There is a phrase that we use whenever we talk about the search for life elsewhere. Follow the water.
And now we think there could be lots of worlds out there that do contain water. But is there a catch? Could they hold too much water? A 2019 study suggests the Milky Way might contain many worlds with thousands of times more water than Earth. Many of these planets are a bit smaller than Neptune. We call them sub-Neptunes. We think we found such a planet just 40 light years from Earth in the constellation Ophiuchus. Scientists have nicknamed the planet the Water World. So far, we're not too sure what GJ1214b looks like. Though Earth is called the blue planet, it's only 0.05% water by mass. As much as 70% of GJ1214b's mass could be water. The planet is thought to have a rocky core, strange oceans, and a hot, steamy atmosphere of water vapor. Unlike Earth, GJ1214b most likely has no complex arrangement of water and land masses.
At land, interacting with that water to have a good location for life.
We think life began in the oceans, but it needed chemicals from rocks to start. Without the interaction between land and oceans, life might not have evolved. We need to find worlds with just the right amount of water and land for life to evolve. GJ1214b looks like a dead end, but the hunt goes on. Exoplanets are opening our eyes to the way the universe works. We must question some long-held assumptions. One standard text predicts the sun will eventually engulf the Earth. But could there be a way out? Do some planets cheat death? In 4.5 billion years, our sun will expand to become a red giant.
When our own star turns into a red giant in 4.5 billion years from now, then it will expand and it will engulf Mercury and Venus and the Earth and the Moon, and it will cook the surfaces of all of those bodies.
But is there a way of escaping this apocalypse? When we look beyond our solar system to the Aquarius constellation, we find hope. Planet HD 203949b is living on borrowed time. It orbits a red giant star.
Red giant stars have burned up all the hydrogen in the middle, and they've moved to the next stage of their development.
A stage that's terminal for a planet orbiting this star.
If you're a planet and you've been orbiting fairly close to your star for billions of years, you might feel like you've got a good relationship, that it's pretty safe, but in fact you would be wrong. In fact, this star that has been taking care of you for billions of years is now going to destroy you.
After billions of years of generating heat and light, a star's hydrogen fuel runs out. The star's core becomes unstable and contracts.
Gravity just pulls everything to the center. And then there's a rebound, everything comes back again. And that creates this big envelope of gas around the star.
The outer layers of gas blow off and expand outwards. As the gas envelope gets bigger, the surface cools to under 10,000 degrees Fahrenheit.
The coolest stars appear red. So late in stars' lives, they are big, bloated red giants.
When a star goes red giant, it expands and it expands outward, and it's likely that it's going to come and engulf some of the planets that orbit that star.
The surface is cooled, but temperatures still exceed 8,000 degrees Fahrenheit.
If you're in the red giant expansion zone, you're going to get cooked.
Exoplanet HD 203949b orbits within this zone. So, is this planet toast? September 2019. We take a closer look at the red giant threatening the planet using a technique called astroseismology. Astroseismology measures the vibrations of stars.
Vibrations go back and forth within the stars, and we can see those by monitoring the surface. One of the things that happens when these stars get to their red giant phase is they start ringing like a bell. When we hear these stars ringing, it actually gives us the most precise information we have about any stars.
The vibrations from the red giant star reveal something highly surprising.
When we analysed the way this star was ringing, we realised it was actually less massive than we'd determined from other methods.
It told us that star probably has already gone through its red giant phase. The star we see today is a little smaller than it should have been quite a while back.
This star has lost some of its outer layers and has started to shrink.
If this star has already gone through its red giant phase and is shrinking again, that means at one point it was bigger than the orbit of this planet.
If the planet was within the red giant zone, it should have been destroyed, but somehow it remained intact.
By all accounts, this planet shouldn't exist, but somehow we see it there today, cheating death. What a survivor.
So how can we explain this escape act?
Could it be this planet changed its orbital position to allow it to cheat death?
Or maybe HD 203949b was never even in the kill zone.
Perhaps this planet originally formed further out and migrated in after the red giant phase was completed.
Maybe some of the clouds of gas shed from the star reached the planet. This gas dragged on the planet, slowing its orbit down. Gradually, the planet migrated inwards after the star reached its maximum size.
And we then evolved down to the system that we see today, a post-red giant star with a planet that shouldn't be there, so to speak.
This exoplanet may have escaped oblivion, but its future doesn't look bright. Its star will shrink down to a cool, dim white dwarf.
If I were a planet, I would be sad at the existence that I would live afterward, just because it would be so different. It would be cold and dark, and I would still be bound with a star that is no longer there in the same way that it was.
This is our future. But it won't happen for another 5 billion years. In the meantime, we can be thankful we live on Earth rather than one of the weird worlds we've discovered in our galaxy.
The more and more exoplanets we find, the more we realize how lucky we really are. We see planets that are too big, too small, too much atmosphere, too little atmosphere, too close to their star, too far from their star, too little water, too much water. Everything on Earth is just right.
Compared to our home world, exoplanets push and twist and stretch the boundaries of planetary science. But every new world we discover expands our knowledge and moves us closer to understanding our place in the universe.
A lot of times we think about other planets and even life in the universe as resembling very much our own. But these weird worlds open the possibility that there's much, much more out there than we had ever imagined.
We've found so many different kinds of crazy worlds in crazy places doing crazy things. It's so interesting. Imagine how boring it would be if we only found our solar system everywhere else.
Entire galaxies fight to the death.
It's a slaughter. It's a massacre.
Only the strongest survive.
If a galaxy wants to stay alive, it has to feed on other galaxies.
In 2018, astronomers used the Gaia Space Telescope to map our Milky Way galaxy. They tracked the movements of 1 billion stars, and they found that some behave very strangely.
Most stars of the Milky Way are orbiting in a sort of regular pattern, but these stars at the center, they're in these highly elongated orbits.
Coming in from very far, swinging around the center of our galaxy and then going back out again. It's a little bit like a comet does.
This group of stars plunges wildly through the center of our galaxy. When you track their direction and speed on a chart, you get a shape that looks a bit like a sausage. What sent so many stars on such a strange path? It must have been a huge event.
We think these stars are the result of a past cosmic collision.
They don't move like stars in the Milky Way because they're not from the Milky Way. These stars are actually alien stars. They're invaders from outer space.
But somehow, rather than destroy our galaxy, these attacks helped transform the Milky Way into a thing of beauty. The beautiful and serene spiral arms hide a history of conflict. Nearly 10 billion years ago, the sausage stars were part of a foreign galaxy. It was on a collision course with our home, the Milky Way. We call this invading army the Sausage Galaxy, or Gaia Enceladus. Gaia Enceladus was a tough opponent. But the Milky Way was 20 times its mass, and that makes a huge difference.
When galaxies interact with each other, size definitely matters. The bigger galaxies are going to dominate over the smaller ones, ripping them apart and essentially consuming them.
Each galaxy contains billions of stars and planets, and a supermassive black hole, millions of times the mass of the Sun. That's a lot of gravitational firepower.
As these galaxies approach each other, you can get tidal effects. The same way that the moon can raise tides on one side of the Earth and the opposite side, one galaxy can stretch another galaxy along a certain direction.
As Gaia Enceladus advanced towards us, our galaxy's superior gravity grabbed hold of the smaller galaxy.
As it approached, the gravity from the Milky Way would have stretched it out.
The Milky Way's gravitational power ripped Gaia Enceladus apart and captured billions of its stars.
Eventually, most of those stars would have then settled down into the disk of the Milky Way and become a part of it.
Despite winning the battle, the Milky Way suffered serious damage.
The collision with the Sausage Galaxy left a scar on the Milky Way. And when we look near the center of our galaxy, we see a bulge that's left over from that collision.
The Milky Way isn't the only galaxy scarred by war. Across the universe, rival armies made up of billions of stars slug it out, leaving behind distorted and damaged casualties of war.
There are things like Artmidor 2026, where you see this eerie glowing face, two big eyes looking right at you from across the universe.
There are galaxies that look like they might have collided with one another and blown holes through each other.
These battle scars give us important clues about one of the biggest mysteries in astronomy. how galaxies develop and grow.
Our local neighborhood of galaxies has 3 major galaxies, but up to 50 smaller ones. All these galaxies are potential troublemakers. Each one of these could be armies that rise up against us.
The 2 most famous galaxies that orbit the Milky Way are the Large and Small Magellanic Clouds. These are 2 independent dwarf galaxies that you can see in the night sky from the southern hemisphere.
We thought the Large Magellanic Cloud orbited our galaxy at a safe distance of 160,000 light years. We thought it would stay that way, and we thought it was harmless. Now, a new discovery shows we were wrong on all counts.
The new factor that changed our view of the Magellanic Cloud is we found out it has a lot more dark matter than we thought.
Dark matter, the most mysterious stuff in the universe.
Dark matter is literally what it sounds like. It's matter that we cannot see, but it has gravity and can affect objects that we can see.
Adding in this extra dark matter makes the Large Magellanic Cloud at least twice as massive as predicted, so its gravity is double what we thought.
So it's not just going to orbit us, it's going to collide with the Milky Way.
Moving at nearly 1 million miles an hour, the Large Magellanic Cloud will not swing past us. It will attack. In about 2.5 billion years, it will smash into our galaxy.
It's gonna plow through the disk of the Milky Way. It's gonna blow a cavity. It might even damage our spiral arms.
Earth sits in one of those spiral arms. Could our planet become collateral damage? The gravitational clash between the invader and the Milky Way could hurl stars and planets out of our galaxy. Earth could be one of them.
Our planet's very close to its own star, so the odds are that you'll just get ripped out along with your star. So we'd be moving along with the sun even as the sun gets jettisoned from our galaxy.
Our view of the night sky would radically change.
We'd be able to see much more of the Milky Way, especially if we got kicked up above the plane of the galaxy. We'd be able to see the whole shebang. Just look at any image of a spiral galaxy. They're gorgeous. Now imagine seeing your night sky filled with the face-on spiral galaxy. That would be like waking up to my face every morning. Spectacular.
If we were unlucky, our home planet could have a close encounter with an invading star.
The odds are very low that another star will pass close by the sun. But those odds aren't zero. It could happen that another star passes close enough to affect the planets.
Where the Earth could end up. It might find its way into the sun. You just don't know. Or there might just be a rain of comets into our inner solar system.
Our own planet might be flung out, in which case this would be a death knell for all life on Earth. I'm not someone who's like a doom and gloom person, but like that would be insane.
You don't know what's gonna happen, but most of the options are bad.
The Milky Way galaxy is bigger than the Large Magellanic Cloud, so we are gonna win, but it's gonna hurt us for a long time.
For billions of years, the Milky Way conquered galaxy after galaxy, tearing its smaller rivals to pieces. But our galaxy is about to meet its match.
In the not too distant future, galactically speaking, a much, much larger battle is due for the Milky Way.
A battle with a local superpower, the Andromeda Galaxy. We thought this huge galaxy might wound us in the future,
We've known for a long time that Andromeda is heading more or less toward us, but we didn't know exactly in what direction. But in recent years, we've been able to pinpoint this a lot better, and yeah, it's heading right for us.
Data from the Hubble Space Telescope shows the two galaxies will collide in about 4 billion years. And it will be a monumental battle.
This collision that is coming, and it is coming, is not going to be anything like the Milky Way has experienced before in its 10 or 12 billion year history. This is a galaxy of comparable size. This is two heavyweight prize fighters coming at it.
Warriors with the same gravitational firepower. Simulations suggest a clash of the Titans.
Each of them with 500 billion stars in them. That sounds like a pretty spectacular collision.
Fights between equally matched galaxies are rare and messy. When the battle kicks off, there will be no good news for either side.
When the Andromeda Galaxy and the Milky Way Galaxy start to get close, they're going to start affecting each other profoundly.
Tendrils of stars are going to be thrown out. Gas is going to be thrown out.
It won't be a single impact.
The first pass is actually not a direct hit. They're going to swing past each other, in fact.
And at this point, their gravitational interaction is going to slow them down, and they're going to come back toward each other.
The galaxies will collide and fly apart again, inflicting more and more damage with each clash.
If you were to go outside and look up, you could see the disk of our galaxy getting ripped apart by tidal interactions with Andromeda.
The two beautiful spiral galaxies will tear each other apart, leaving one vast elliptical galaxy.
The fate of the Andromeda Milky Way battle is that they will merge. This is going to be one gigantic galaxy.
And that presents a problem. What are we going to call this new galaxy? Of course, my nerd colleagues have come up with names like Milkomeda, Andromeda, whatever. Those are corny. We should just call it Hakeem.
With 1 trillion stars, it will be one of the biggest galaxies in the universe.
In the Hakeem galaxy, things are going to be completely new. First off, it's going to be a really good-looking galaxy. Let's get that straight from the get-go. Second, it's going to be powerful, and I'm talking powerful. This may be the most remarkable galaxy in the history of the universe.
Milkomeda, or Hakeem, if you prefer, will become the undisputed boss of our cosmic neighborhood. Its calm appearance concealing a history of violence. Cosmic wars are vicious. They destroy many galaxies. But violent conflicts can also give galaxies new life. Case in point, galaxy NGC 4485.
NGC 4485 has a nickname of the Two-Face Galaxy, like the Batman villain, because it has two different halves of the galaxy doing completely different things. Half of the galaxy is sort of old and calm and relatively quiescent, whereas half of it appears to be undergoing a sort of fireworks display of new star formation.
Why are new stars only born in one half of this galaxy? We found a clue on the edge of a photo taken by the Hubble Space Telescope. It was evidence of an attack by another galaxy.
We think that another galaxy passed through it just off-center in a way that strongly perturbed the gas on one half of the galaxy.
The Two-Face Galaxy's skirmish gave it a gravitational jolt, forcing clouds of gas together. When two galaxies collide, the gravitational duel can trigger a huge burst of star formation.
And when gas clouds collide, they compress. And when they compress, you get knots in them that can compress more and form stars.
So you can think of these collisions as very violent events, but ultimately it can breathe new life into a galaxy.
But the spoils of war don't last long.
In the short term, the victor galaxy can come out glorious with so many new stars. But this celebration is short-lived because that round of star formation quickly uses up the material available.
If a galaxy wants to stay alive, it has to feed on other galaxies.
So galaxies constantly need to raid new targets. And that raises an important question.
What happens if there's a galaxy just alone in space, nothing else is colliding with it, sort of a pacifist galaxy?
The poster child for these peace-loving galaxies is NGC 1277.
It basically hasn't formed new stars in the last 10 billion years, so it's kind of the veteran's home of galaxies.
NGC 1277 lives in a rough part of the cosmos called the Perseus Cluster. Thousands of other galaxies surround NGC 1277, and they are all ready for a fight.
So you might ask, why hasn't it had encounters with other galaxies that might rejuvenate it?
The answer, once again, is gravity.
NGC 1277 sits inside this massive galaxy cluster that has a ton of mass. And if you look at its position, it's fairly near the center of the cluster.
The combined gravity of thousands of galaxies pulls on NGC 1277, accelerating it to 2 million miles an hour.
And so it has spent the last few billion years traveling faster and faster until now it's almost at its fastest pace.
NGC 1277 has no chance of grabbing new gas to make new stars. It's dying. All it has left are old red stars.
When it comes to galaxies, red is dead. No new stars means no big stars, no blue stars, just small, dim red dwarfs.
Galaxies that don't fight just fade away.
And at that point, the history of the universe becomes really kind of boring. All the stars will simply start to die out. Eventually, there will be the last star formed in the Milky Way, with no new galaxy bringing fresh material. Without galaxy collisions, the universe dies.
Galactic battles mix things up and replenish gas supplies. And our own galaxy has reaped the benefits. Clashes with the Sagittarius dwarf galaxy occurred at the same time the Sun formed.
It's possible that we owe our very existence to the collision with the Sagittarius dwarf galaxy.
Maybe the gas that ultimately gave rise to the birth of our solar system once came from another galaxy entirely.
So galactic wars are both creative and destructive.
These collisions got us to where we are today, and they're going to determine the future of all the universe.
So what would happen if a small asteroid or comet hit the Earth tomorrow? Something 100 to 150 feet across, like the one that made Meteor Crater in Arizona. Well, if we're lucky, it'll hit out in the ocean. Just make a big splash and pretty much that's it, it's gone. If we're unlucky, it's gonna hit a sizable city, and in that case, we're gonna be in a lot of trouble. The first thing you're probably gonna notice is you'll have a second shadow, because now there are two sources of illumination in the sky. One is the sun, and the second one is the fireball. The next thing you'll probably notice is it's getting hot as the fireball gets closer to you. When this asteroid hits the ground, from where you are, there's going to be a moment of silence, peace. But that's not going to last long because then comes the blast wave. That's moving at about 700 miles per hour, and it's going to wipe out everything in its path. It'll demolish an area of a city 16 blocks on a side. It's like a nuclear explosion. What will be left is a smoking crater a mile across. If you were 10 miles away from the blast, you might stand a chance of survival, but even then, there's fire and earthquakes, and that's not to mention the gas and the dust thrown up into the atmosphere. That's going to affect climate, health, even agriculture. And it's not just the impact on this one city, the effects will be global. Our civilization is very advanced, but it's also much more fragile than it used to be. Cities are interconnected, interdependent, and what affects one is going to affect all of them. Planetary scientists call these small to mid-sized asteroids city killers. Accurate, but a little cute, because we really should be calling them civilization killers. We really should be worrying about these things more than we do.
Asteroid detection is an extension of our natural desire to protect ourselves. Now, the asteroids are really tiny, looking at the whole scale of the solar system. And so what we'll be doing is looking at these points by their movement. This is a plot of the near-Earth asteroids we knew of 20 years ago, only a few hundred. 20 years later, now we know that there are over 20,000 near-Earth asteroids, and we continue to discover 40 more every week. The asteroids we're really concerned about are called potentially hazardous asteroids. These are at least 500 feet across. They are within 4.5 million miles of Earth, and there are at least 2,000 of them that we already know about. This is the asteroid I'm really concerned about. It's called Apophis, or some call it the Doomsday Asteroid. And on April 13th, 2029, Friday the 13th, it's going to come within 20,000 miles of Earth. These blue dots are satellites orbiting the Earth, and Apophis will be closer to Earth than some satellites. It's clear that we're going to be safe when Apophis comes near Earth in 2029, but Apophis will be so close to Earth that it could get a kick from Earth's own gravity, so that the next time it comes around in 2068, it could be on a collision course toward Earth.
Identifying dangerous asteroids is just the first step in protecting the planet. Once we found them, we need to stop them from hitting Earth.
We're going very fast. We're going at 15,000 miles an hour.
We're going to the Didymos system. It's about 850 yards across and has a small moon orbiting it that is 175 yards wide, Dimorphos.
We see the moon for the first time about 30 days out. And 30 days out, we only see the larger moon, and it is just 1 pixel. The spacecraft makes its own decisions and is going to say, oh, that was the big asteroid, and now I see the moon, and it's going to start guiding towards the moon. When we hit the asteroid, all of the debris is going to kick off, and that's actually what's going to give us an extra kick and propel the moon forward. It's a very small change, right? 0.5 millimeters per second, but 0.5 millimeter is enough to change the orbit of the asteroid. You know, I worked on a lot of science missions in the past, and it's very hard to talk to the public about what is it that you do, right? You talk about magnetic fields or electrons, and people are like, I don't care. However, I think everybody can relate to the fact that we're going to, you know, possibly save humanity.
But here's the bad news. A lot of asteroids they slip through the system. So here's the thing. Despite years of searching, we know there are plenty of rocks out there that we haven't identified yet. Let's just look at the figures. You know, there's at least 9,000 rocks that we know that are out there that are bigger than 450 feet. But then there's at least another 15,000 that are out there that are smaller. And then there are the 150-foot size asteroids that the astronomers call the city killers. We haven't identified those at all. And so those known unknowns, those are the real threat. The first that anyone knew about the meteor that struck Chelyabinsk was when the fireball went screaming across the sky. And that meteor that the weather satellite saw over the Bering Sea, well, that was a surprise too. But then there are the objects that come right out of left field. In 2017, astronomers in Hawaii discovered Oumuamua. What made Oumuamua special, it was the first time astronomers had ever seen a giant rock coming from outside of the solar system, from the distant stars. And the thing about it was, by the time they'd seen it, it was already halfway out of the solar system. And in 2019, we had another visitor from deep space, a comet named Borisov. And once again, its appearance in the solar system came as a complete surprise. These interstellar objects, they're real curveballs. They come in through the solar system on these crazy trajectories that are impossible to predict and at enormous speeds, not tens, but hundreds of thousands of miles per hour. That's faster than anything within our own solar system. Now, if one of these babies shows up and is on a collision course with Earth, well, we're not going to know about it until it's way too late.
Dinosaurs ruled the world for 160 million years, then gone. Taken out by one rock. They didn't stand a chance. What about us?
Major asteroid strikes are going to happen. They've happened throughout history. It's just a matter of time.
It may not be in the next decade, it may not be in the next century, but over the course of millions of years, there's going to be an asteroid large enough to wipe out a lot of life on Earth.
The odds of getting hit, say, in the next year are very low. But the problem is, if it happens, the damage is catastrophic.
This is the one natural disaster that we have within our means to actually prevent. The challenge, though, is we've got to start practicing.
We should be able to develop the technologies that could perhaps break the asteroid apart, or perhaps gently nudge it into a different orbit so it wouldn't strike the Earth.
Could we survive an asteroid impact? Well, it depends on how big it is. Even if it's a pretty big fireball, that's not that big of a deal. But if it gets past a certain size and we let it through, yeah, this could be bad. It could hit a city, wipe it out. And we've seen what happens in situations like that in the past. These have a global impact economically and in many ways. So our best bet really is to make sure they do not happen.
If it were to happen, life would probably go on. Maybe not with us, but it would probably go on.
When we think about existential threats to human civilization, we think about things like terrorism or pandemics, or, the very, very serious threat of climate change. But if we were going to ask what could completely wipe out human civilization in an instant, well, that's really an asteroid. And that's really why we need to think about it more.
The race is on to solve the mystery of the fastest particles in the universe.
Our sun looks like a beautiful glowing orb, bringing energy and light to Earth and allowing life to thrive. But if you look at it up close, you'll see a tumultuous storm of events.
The amount of energy the sun is emitting every second is the equivalent of 100 billion 1 megaton bombs. It's a dangerous neighborhood.
The entire outer third of the sun is a boiling cauldron, and tied up in that plasma are magnetic fields that get tied and twisted, and energy is stored in them, so they rise toward the surface. And there they rearrange, they reconnect, they twist, they spin.
When the magnetic field lines snap, energy bursts out.
And sometimes that energy release is explosive. And that's what results in flares, which are these huge bursts of light.
It's a deadly hail of particle bullets. And out in space, our astronauts are caught in the crossfire.
Cosmic rays represent one of the greatest dangers for human spaceflight.
Where radiation levels from cosmic rays are 200 times greater than on Earth. And that is just the start.
One of NASA's big goals is to send humans to Mars, and that is a long way away. At least a 6-month journey, and more often about a 9-month journey. That's a big problem.
I am hoping that one day I can go to Mars as an astronaut, but I'm definitely afraid of cosmic rays, and the more that I read about it, the bigger of a threat it seems. So I think that NASA and other space organizations are going to need to work on how to protect their astronauts in these really dangerous situations.
Only one group of people have been exposed to these high levels of cosmic rays: the crew members of the Apollo missions. July 1969.
It's one small step for man, one giant leap for mankind.
One of the astronauts, Buzz Aldrin, sees something strange.
During Apollo 11, Buzz Aldrin reported seeing tiny little flashes sometimes when he was looking around. That's pretty weird, but what's weirder is that he saw them when his eyes were closed. You have to realize that space travel was new back then. Nobody knew what was going on.
NASA asked the astronauts to wear a light-proof box on their heads. It's not a blindfold, it's a cosmic ray detector.
Don, this thing was made for about a size. Mark, left eye, a streak starting in the center. Mark, right eye, dot, center. The left eye was a streak starting in the center going out to the right. It increased in size as it went from right to left.
The astronauts described the flashes as spots, streaks, and clouds. NASA examines the astronauts' helmets. They find tiny tracks etched through them, evidence of cosmic ray impacts.
And some of these burrowed all the way through the helmet, which means it ended up in the astronaut's brain, which just makes me feel weird to think about.
What might that long-term radiation do to your brain, to your ability to reason and problem solve in one of the most dangerous environments that humanity's ever placed itself?
The farther we venture from our home planet, the more danger we face. To find out more, scientists bombarded human cells with man-made cosmic ray particles. They discovered cosmic rays physically cut through DNA, chopping it apart.
You can trigger that cell to turn tumorous, to start producing a cancer.
In 2019, scientists took the experiment further and simulated a trip to Mars for mice. For 6 months, they blasted the rodents with a steady stream of lab-made cosmic ray particles.
The experiment found profound alterations to the mice's normal behavior. They learnt new tasks much more slowly. Their memory was affected, and they forgot things they had already learned.
They were more anxious and prone to giving up on tasks they'd normally complete. But down on Earth, we're protected.
Out of all of the rocky inner planets in the solar system, the Earth is the only one to generate its own deflector shield against this cosmic radiation.
The Earth creates its own magnetic field.
The Earth has this wonderful, active, molten core of metal. All of that metal is moving around inside the Earth, and that moving metal generates a strong magnetic field. These cosmic rays are electrically charged, they follow a magnetic field, so our magnetic field deflects most of the cosmic rays around it.
The shield is not perfect. Some cosmic rays do get through, but then they hit our second line of defense, the atmosphere. The atmosphere is like a missile defense system. Cosmic rays collide with air molecules, shattering into safer, smaller particles. The most common ones are called muons.
There's as many as 4 of these cosmic rays passing through my hand every second. They're passing through your body right now.
Muons are so abundant, we don't need a high-tech observatory to detect them. Just a few things you'd find in a high school science lab.
A small aquarium that I've attached a small piece of felt to the bottom. Some frozen carbon dioxide, some dry ice, hence the safety gloves. A flat piece of metal like this, some isopropyl alcohol. Then I flip the whole thing over onto the bottom and I wait. And because that bottom layer is so cold from the dry ice, it forms a super saturated cloud of alcohol vapor.
When the charged particles pass through the cold vapor, they create tiny, ghostly trails.
What we're looking for are the muons, the subatomic particles generated when a cosmic ray strikes the upper atmosphere.
Each silvery thread in the cloud chamber is the sign of a cosmic ray. Muons can pass through hundreds of feet of solid material, giving them another surprising role as subatomic archaeologists.
What's astonishing is that these radiation particles, things which are very dangerous to you if you're exposed as an astronaut in outer space, have actually got a really useful application on the surface of the Earth.
2017, Egypt. The Great Pyramid of Giza is thought to hide an undiscovered burial chamber. It could hold priceless artifacts. So, rather than excavating, scientists use muons to look inside.
If there was an empty chamber in the pyramid, then more muons would make it through down to their detector, just like more sunlight would make it through a gap in the clouds.
As the muons pass through the pyramid, they lose energy and are deflected or absorbed. But if there's a cavity that they can pass straight through, that lets scientists see inside the pyramid.
They found a spot underneath the Great Pyramid where more muons were coming through than expected. More than you could explain if the area above that spot was full of just stone. This is a previously unknown empty chamber in the Great Pyramid. What an amazing archaeological discovery. What's in there?
The cosmic rays don't damage the pyramid.
Muons are already streaming down on us from above. It's non-invasive. It's not destroying the Great Pyramid as we're trying to study it. It's nature's own experiment.
We've also used cosmic rays to map the Fukushima nuclear reactor and to study the interior of volcanoes.
These radiation particles also give us an incredible ability to peer inside things we'd never be able to look inside or survive or experience as a human. It's almost like being able to take an X-ray picture inside a volcano.
Cosmic rays are the ultimate space travelers. Their awe-inspiring speed allows us to unlock hidden processes and test our theories of physics.
They're way more energetic than anything we can do in a laboratory on Earth. So that means we can unlock all kinds of new domains about physics at the highest, most extreme energies.
They're our best link to the farthest reaches of the cosmos.
To me, it's really exciting that we're actually sampling pieces of matter from distant stars, from distant galaxies, and we're getting them here at Earth and studying them.
Maybe they're coming here to plunder our world.
They may be up there watching us, and we're the exhibit.
Back in 1950, one of the world's leading physicists, Enrico Fermi, posed a simple question. If alien life is so probable, where is everyone? Why haven't aliens colonized the galaxy? The thing is, life needs to overcome a series of hurdles before it can become a spacefaring civilization. Life on Earth began at least 3.5 billion years ago in the form of single-celled organisms. We're talking bacteria, protozoa, archaea. The first hurdle to spacefaring is really basic. Living things need to evolve complexity. This took a long time. Complex multicellular creatures started to evolve only 1.5 billion years ago. It's only in the last 20 million years that some mammals started to evolve the brain power that we call intelligence. Even then, it was only about 2 million years ago that one of those mammals, a human ancestor, learned how to make tools and light fires. And it's only in the last 6,000 years that we've had the social cohesion to form civilizations, so that we can share ideas and accumulate knowledge and pass that from generation to generation. Finally, it's only in the last 60 years that we've made our first small steps into space. So here on Earth, the journey from the start of life to the space age has taken 3.5 billion years.
Liftoff. We have a liftoff.
We're asking alien civilizations to make a similar journey, presumably over a similar length of time. But whenever I think of these hurdles, I always come back to the math. If only 1% of 1% of 1% of planets have gone down the same route, there would be 100,000 advanced civilizations in our galaxy alone. So there should be some alien civilizations out there somewhere. We'll just need to look a little harder.
For me, it's a slam dunk that aliens really exist. The only challenge is finding them. In October 2017, we sent the first message we designed for advanced extraterrestrials. Of course, we don't know the aliens' language, so we used the universal language, math. Those two different tones represent a binary code, the simplest numbering system. We aimed this transmission at Luyten star. In 2017, we discovered that there is an Earth-like planet orbiting within its habitable zone, which means it could potentially have life. Now, Luyten star is 12 light years from Earth, so that means the earliest we could receive a response is 2042. Other targets are much, much farther away. So realistically, it could take hundreds or even thousands of years to get a reply back. So if we want to have even a simple conversation with an alien civilization, we need to make sure we're around for a long, long time to talk. When we imagine aliens coming to Earth, we imagine they're coming to destroy us. I mean, that's what science fiction movies tell us all the time. And the reality is completely different. Think about it logically. What would they want from us? Maybe they're coming here to plunder our world. Columbus came to the New World to find spices. The conquistadors came to get gold. And it didn't turn out well for the indigenous people in either case. But what is there that super advanced aliens might want to plunder from us? What about water? All life needs it. We used to think it was rare in the universe. Now we know it's pretty common. In fact, in 2020, a NASA study showed that of the 4,000 planets we know of, many of them are water worlds. Maybe they want to harvest us for food. Get real. At best, we'd be indigestible, given that we have completely different biologies. In fact, it's incredibly difficult to imagine what we have on Earth that is so rare that an alien would come all this way to get it. To me, the most compelling reason is curiosity. I suspect aliens, if they're super advanced, are also going to be super curious. Curiosity and progress, they go together. Like donuts and jelly.
Let's suppose that aliens are curious about us and they want to know more about what we bipedal apes are up to. So this is called the zoo hypothesis, right? And that makes sense. We're in the zoo and they're watching us. Well, why don't we see them? Why don't they make themselves known to us? Well, it's not that they're shy necessarily. It's more that they're so technologically advanced, they don't want to freak us out. This idea comes up again and again, especially in science fiction, right? Non-interference. It's kind of like the Prime Directive in Star Trek. And the whole point is, right, they're observing us. It's like a scientific experiment. They want to see how we behave naturally. And if we know they're out there, we're going to change the way we work. Well, there's a variation that I think is pretty interesting, and that is, yeah, they're not just watching us, they're actually changing us, they're interfering with us on purpose. They have some goal, something that we need to achieve that they have in mind, and they're guiding us in that direction. Maybe there's some level of technology that we're supposed to achieve, and then when we do that, they'll make themselves known to us. Until then, we're just here going about our business in blissful ignorance.
Even if aliens have the means and motive to travel across space, it doesn't really make sense for them to travel themselves. Living things just aren't built for the vacuum of space. Zero gravity, high radiation, freezing temperatures. Space travel takes its toll on the body and mind. So increasingly, we send machines instead. These machines can do the tasks that we set them in space without us having to be there. They can stand in for humans. I've been involved in designing robots to explore space for 10 years now. Robots like the Mars rover. This Mars rover is a laboratory on wheels. It's got a 2-meter drill, stereoscopic cameras, ground-penetrating radar, and it can land and navigate on Mars all by itself. Unlike astronauts, robots don't need food, water, oxygen, or a pressurized suit. They don't get tired or homesick, and they only need a one-way ticket. Really, why send humans when robots can do the same job so much more easily? It just doesn't make sense.
Robots like these would need to be able to think independently and problem solve for themselves. They'd probably need to self-repair. They might even need to self-replicate. They'd need to be way beyond any level of AI we've achieved so far here on Earth. It's reasonable to think that aliens would come to the same conclusion and send their own advanced robots through space. So when and if contact does come, it's likely that it would be not with an alien itself, but with an advanced alien AI. ET AI.
For us, intelligence is about acquiring knowledge, then using it to perform complex tasks. We humans like to think that we are pretty good at it. After all, we've built a very complex world. But perhaps intelligent machines could use their intelligence to become super intelligent. And that's the great fear, that no matter what safeguards are put into their programs, there will come a point where what a machine wants and what we want are no longer the same things. The machines will simply take over. If that is true of machines designed by humans, then what if we encounter machines designed by aliens? I think we might be to them like a bug is to us. I don't hate bugs. I don't set out to kill them. But if they get in the way of my primary goal, like walking across the grass, it's too bad. I barely give it a second thought. That's the fear about alien AI. If it comes to Earth, or we run into it on our travels in space, we wouldn't stand a chance. It's nothing personal or malicious, but if we were in their way, we'd simply be swept aside.
Even if there's no alien invasion, it's ridiculous to think that we're alone in the universe. Out of the million, billion, trillion stars, some of them have to be the home of intelligent life. As Carl Sagan said, the universe is a pretty big place. If it's just us, seems like an awful waste of space.
Four and a half billion years ago, the solar system was still a pretty wild place. We're approaching the end of the formation of planets. Earth would still be growing.
In fact, you wouldn't recognize the Earth at all. For example, no moon. The Earth did not have a moon when it first formed.
The young Earth orbits the Sun with other infant planets. One of them is an object scientists call Theia. And it's on a collision course with our home. The impact melts rock and throws out over 1 billion tons of debris.
During this incredible collision, these two planets were literally broken apart and combined into one big planet. Huge chunks of Theia stayed together as the now molten Earth began to form anew.
The giant slabs of Theia sink down into our planet and lie undiscovered for billions of years. Earth reforms from the ruins of both planets. When these two planets combine, parts of Theia's iron core merge with Earth's.
So that means that Earth collected a much bigger core than it might have possessed on its own. This is good news for us because the core is the source of the magnetic field that protects us.
Liquid metal flowing around in the outer core generates Earth's magnetic field, a protective shield from the sun.
The sun can actually output billions of tons of high-energy protons and electrons in a single burp. That eventually would have stripped away our atmosphere. If it weren't for that active core and that magnetic field, we would look like Mars, just sort of a bare and barren desert.
Thanks to Theia's extra iron, Earth's molten outer core is large, so it cools slowly staying molten and keeps on generating a strong magnetic shield. The catastrophic impact helped life in other ways,
causing a huge disk of debris spread out from the Earth, out of which formed the Moon.
After the collision, the Earth tilts on its side and spins incredibly fast. A day only lasts a few hours. The Moon's gravitational pull on our oceans creates tides and slows down the Earth's spin, creating a world primed for life. But then, the biggest bombardment in history smashes into the Earth. From the moment our planet formed, we've been under fire. 2021, a fireball streaks across the night sky in Europe. 2018, a 1,500-ton meteor explodes over the Bering Sea with 10 times the energy of an atomic bomb. 2013, an asteroid explodes over Russia, injuring over 1,000 people.
The Earth is hit by quite a few asteroids every day. You see them as shooting stars, meteors in the sky.
These events are violent and destructive, but these space invaders also brought something every living planet needs: volatiles.
When we say volatiles, what we mean are elements that are really light and easily moved around. Often they're gases, so that's oxygen and water and carbon dioxide and just all those light elements that are really important building blocks for life.
Young Earth was a dry planet. 4 billion years ago, a storm of giant asteroids and comets hits the Earth. Some are tens of miles wide. They bring the volatiles that help fill the Earth's oceans and build its atmosphere. But cosmic deliveries can both give and take.
The importance of impacts for atmosphere could go either way. You could have a really big, really powerful impact that blows away the atmosphere of a small fledgling planet. Or you could have a bunch of small impacts of water-rich asteroids that are simply contributing water and volatiles and new chemicals to the surface that might help the atmosphere that's already there.
Firing a mini meteor at 2,000 miles an hour into this chemical soup triggers a reaction between the basic organic elements, creating amino acids.
We call amino acids the building blocks of life. Really, they're the building blocks of proteins, and life needs proteins to exist. But that's why they're so important. Without amino acids, there's no proteins. Without proteins, no life as we know it.
The experiment proves that meteorite impacts can help build the components for life. Cataclysmic events go hand in hand with human evolution. Some knocked us back, and others, like the event 66 million years ago, gave us a push forward. 66 million years ago, a massive asteroid crashes into the Earth. It triggers a huge extinction event. Without it, humans may have never evolved. The impact throws trillions of tons of rock and dust into the air. The rocks heat up as they fall back to Earth, setting the planet on fire. The impact also throws up soot, choking the atmosphere.
Now the skies are blotted out by all these materials, so the sun is no longer shining brightly on the surface.
Plants need sunlight to photosynthesize. Without this vital energy source, many species die out. With their food source gone, plant-eating dinosaurs starve to death, followed by their predators. Again, the dice roll is in our favor. Most dinosaurs become extinct, paving the way for the evolution of mammals, leading, eventually, to humans. Without the asteroid impact, we wouldn't be here. Before the asteroid strike, conifers and ferns dominated the tropical forests of South America. But afterwards, falling ash from the impact enriched the soil, and fast-growing, flowering plants took over.
The impact was very hard to recover from, but it actually opened the opportunity for a greater diversity of plant life, which ultimately has benefited us as humans because it has allowed us to have more food sources.
This new world order eventually gave rise to the modern Amazon rainforest, home to 10% of all species on Earth.
It really destroyed and remade our entire environment. The world grew back, of course it did, here we are, but it changed everything.
And another age, maybe, just around the corner.
We should absolutely expect that at some point in the future, and I'm not saying you should lose sleep over it, but at some point there will be another mass extinction.
For a long time, we thought that the death of a star was the only way a black hole could be formed. But now we know there's another way to form a black hole. You remember neutron stars? The super dense remnants of a star whose death wasn't quite dramatic enough to create a black hole. Objects the size of a city, but as heavy as the sun. Well, they tend to hang out in pairs that orbit each other. We call them binary neutron stars. In fact, we reckon there are 1 million binary neutron stars in our galaxy alone. But the stars can't keep orbiting each other forever. Over time, the gravity of the two stars pulls on each other, speeding them up, and they start to spiral closer and closer to each other. And eventually, they collide, producing a colossal explosion called a kilonova. A kilonova explosion is so big that it shakes space itself, sending out distorting waves that ripple through the universe. And what becomes of the neutron stars after the collision? They disappear into a singularity, becoming a black hole. So there you have it. 2 ways for a star to become a black hole: a supernova or a kilonova. Now, while supernovae happen in our galaxy every 50 years or so, kilonovae are much rarer, happening about every 50,000 years. But remember, the Milky Way is 13 billion years old. So that's plenty of time for millions of black holes to have formed in our galaxy alone. Perhaps even hundreds of millions.
For the most part, the universe appears to be pretty stable. When you look into the night sky, the stars seem to be static and unchanging.
But that masks the reality. There are objects out there of terrifying power. Rogue black holes.
Normally, black holes form as stars end their lives in colossal explosions, throwing out material and intense radiation into the universe, leaving a potentially dangerous black hole spinning where the star used to be.
But it's safe because it's stuck in one place. That's not always the case. Every so often, the explosion isn't quite even on all sides, which sends the black hole barreling off into space at tremendous speeds. Runaway black holes. It sounds crazy, like science fiction, but recent evidence suggests they really do exist. In 2017, a Japanese radio telescope took an image of gas and dust left over from a supernova. What we're looking at here is a cloud of gas, much like any other you'd find in our galaxy. But what's amazing about this particular image is this streak coming down the middle here. It's been torn out of the cloud of gas by something moving through at some 60 miles every second. They call it the bullet. It's so destructive that the streak it's created is 11 trillion miles long, 6 times the size of the solar system. And it's thought to be one of many runaway black holes shooting across the universe. There could be one heading for Earth right now.
What would happen if a black hole were hurtling towards Earth? The short answer would be gravity. A lot of gravity. As the black hole approaches, we're going to start to feel gravity in a very different way. And when it gets close enough into the inner solar system, that's when things are going to kick into high gear. The gravitational pull of the black hole is going to create walls of water hundreds of feet high. Those will sweep inland and wash away cities. If you survive the tidal waves, you're in for a treat. When the black hole is about 7 million miles away, the gravity of the black hole pulling you toward it will balance the gravity of the Earth pulling you down. In other words, you'll be weightless for a few seconds until the black hole gets closer and then you're accelerated into it. The downside of this is that it puts a colossal strain on the Earth. There will be earthquakes everywhere, wreaking havoc on city after city. Volcanic activity will be constant, and then continents will be torn apart. If by some chance you happen to be standing where the Earth's surface used to be, you're going to start to feel the full power of the black hole's gravity. Your head is 6 feet closer to the black hole than your feet, and that means that your head is going to be pulled so much harder that the black hole will rip you apart. You'll be a long, thin stream of atoms as you fall toward the black hole past the point of no return. Well, that's the bad news. The good news is the chance of any of this happening is incredibly small. Space is vast and black holes are tiny. The odds of one getting close enough to the Earth to affect us are trillions and trillions to 1 against. I'm not worried about it. We're safe for now.
Remember how black holes can also be created by kilinovae? The explosions created by the collisions of neutron stars? Well, it turns out there are byproducts of these explosions that can be more dangerous and deadly than a black hole. They're called strangelets. To understand strangelets, you need to understand what's going on inside a neutron star. The physics here is mind-bending, almost impossible to comprehend. But one way to make sense of it is to think in terms of pasta. Inside a neutron star, the pressures become so intense that the protons and neutrons that usually repel each other start to touch. They meld together, squishing and squeezing until the nuclei deform and fuse into semi-spherical shapes. They look like gnocchi, so we call this the gnocchi layer. Near the center of the core of the neutron star, these nuclei are squeezed so hard that they then rearrange into long cylinders, like spaghetti. Nearer still to the core, the pressure is so extreme that the nuclei get squished into larger sheets. The lasagna layer. Now we're almost at the core, and this is where it gets seriously weird. Here, neutrons and protons break down into elementary particles called quarks. All the different pasta layers dissolve into one kind of nuclear soup that we call strange matter. And it is well named because it is truly strange. It eats everything it comes in contact with, turning it also into strange matter. This isn't much of a problem while the strange matter is locked away inside a neutron star. But when neutron stars collide and form explosions that produce black holes, this strange matter can be released in blobs known as strangelets. These blobs can travel through space with the power to break down everything they come across, turning all normal matter into strange matter. This could be the most dangerous substance in the universe.
Strangelets. We astrophysicists have never seen them. And we don't really know if they exist. But if they do, they could be out there working their way through the universe to lethal effect. You see, strangelets could have this crazy superpower, the ability to infect all the other matter they touch, radically changing its properties. So what would happen to this, all this, if a strangelet moving through space were to hit the Earth? One theory is that when strangelets start interacting with matter here, it's going to trigger what physicists call a phase change. A phase change is when matter changes state. You know, like when liquid water freezes into ice, or when a solid, like this solid carbon dioxide dry ice, changes into vapor. So there's a theory that says a single strangelet passing through the Earth would trigger a phase change. All of the matter, the normal matter on the Earth and in your body would flip, and it would become strange matter. The world as we know it would disappear. Within a day, the Earth will have collapsed on itself, leaving nothing but a super hot, super dense ball of mush about the size of a football field. So, how likely is this scenario? Well, you know, in truth, we don't even really know if strangelets exist. But what they are is one theory, one possibility that exists in our exploration of matter at its most basic, most fundamental level. But if this possibility were true, well then, one day, all of us could be toast.
In the cosmos, killers are on the loose. Stranger than any black hole.
Within a day, the Earth will have collapsed on itself.
Is this our destiny? Destroyed by strangelets.
We still have so much to discover about black holes and the universe and their role within it. The closest black hole we've found is about 1,000 light years from Earth, but there could be ones that are even closer. We expect there to be hundreds of millions of black holes in our galaxy. So yeah, they could be there. We're looking for them.
Although we've learnt a huge amount about black holes in the last few years, we'll almost certainly never know what truly lurks inside. And that's because the thing that we use to learn about the universe is light. That's what carries the information. And a black hole doesn't let light escape from it.
Black holes really exist at the edge of what we understand as a species. They're a place where Einstein's theory of general relativity breaks down. So I would say the most important purpose black holes have right now is to help us get to a new realm of understanding the nature of the universe.
A strange, invisible assassin stalks its prey. It attacks and hijacks the cell, forcing it to produce hundreds of new raiders. This is what happens when the microcosmos turns on us. In 2020, we experienced this invasion of the body snatchers firsthand. A tiny virus caused a global pandemic, COVID-19.
This pandemic makes me see the world completely differently because there was an invisible universe, one that covers me and is within me, that I pretty much ignored for the most part.
The microcosmos is complex. While some parts kill us, others keep us alive.
The microcosmos is important for us to survive, in order for us to do all of the things that our body does, in order for us to live and grow and thrive.
Our lives depend on the microcosmos. The air we breathe and the surface of the earth around us has been profoundly affected by the microcosmos.
The microcosmos has also taken over our bodies. We're only partly human.
The fact that so little of my own body, of everyone's body, is as human cells, kind of leaves you wondering what's the rest of it made of, right?
It is astonishing that we share our bodies with over 380 trillion viruses.
The question, are viruses alive, is actually more difficult to answer than you might think. What is the definition of life? What does it mean to be alive?
NASA's definition of life is a self-sustained chemical system capable of Darwinian evolution. Entities that feed, make energy, and reproduce.
Viruses can't do that on their own. They have to have a host cell to do that. They have the genetic material that they need, but none of the machinery. So they really have to infect a host. If not, they're useless.
Inside a host's body, viruses latch onto the surface of cells and then take control.
A virus's life cycle is effectively to hack another cell.
They have to inject that genetic material into a living cell, and then the cell is hijacked and starts making copies of the virus.
Which then have to burst out of this cell, almost literally like that gory, grotesque scene in Aliens.
Viruses have to have a host cell to replicate. So if you find a virus, in essence, you found life.
Viruses might lead us to extraterrestrial life. Now, new research suggests that life on Earth may have come from space.
There's this idea that microbes could have hitched a ride on a chunk of an asteroid that would fall to Earth.
They could form on a different planet. Something hits that planet, the rock that they're sitting on gets lifted, and then hits the Earth as a meteorite.
The idea of hitchhiking bugs sounds a bit wild. 4.5 billion years ago, many infant planets orbit a new star, our sun. This infant solar system is chaotic. Collisions between planets are inevitable. The young Mars is in the line of fire. It already has primitive oceans, and perhaps primitive life. A huge space rock smashes into the surface. We call the event the Borealis Impact. It blows quadrillion tons of rock into space.
It's not crazy to think that one of these chunks of rock traveling through our solar system has some hitchhikers on board.
So the idea of moving life around the solar system or around the galaxy on asteroids poses a lot of different challenges.
Events like the Borealis Impact ejected so much rock from Mars, there were lots of opportunities for hitchhiking bugs to run the gauntlet of space. But could they survive the journey? To find out, astronauts on the International Space Station grew simple bacteria outside in space.
After a year of being in open space, miraculously, some of these microbes survived. It's incredible.
These microbes just could not be killed, even though they were in the worst possible environment for life.
We got evidence for the widespread distribution of these building blocks in 2017. A strange space rock called Oumuamua raced through the solar system.
The weird thing about Oumuamua is that it's clearly on a trajectory that came from deep space, interstellar space, that it literally came from another star.
Even weirder, its color. Its surface is red.
And so that raised a lot of questions about what its composition could be. And one possibility is that it's actually filled with organic materials, which tend to have those colors, especially when exposed to the space environment.
This suggests organic materials may travel through interstellar space. The microcosmos gave us life. Now, it could wipe us out. Global warming is releasing potentially lethal bacteria and viruses. Siberia, present day. Rising temperatures are melting the Arctic permafrost, revealing land sealed under ice for tens of thousands of years.
As that permafrost begins thawing out and melting with climate change, maybe that will release pathogens that have been locked up for potentially thousands of years.
In 2014, researchers investigated melting Siberian tundra, a region larger than the USA.
I've seen a lot of science fiction movies where scientists are digging around in the ice and find something bad from a long time ago.
Scientists took samples of tundra soil to the lab and examined the contents. They found a frozen ancient virus.
A virus locked in ice from over 30,000 years ago. Isn't this the start of like every horror movie? A scientist uncovers some deep secret of nature and then just open it up and unleash it on the world.
Just like in a B movie, the team fed the virus to living single-celled creatures called amoebas to see if the virus still functioned after being frozen for thousands of years. The virus woke up, attacked the amoebas, and replicated.
Bringing this ancient virus back to life was sort of waking up the undead.
Scientists had no idea how this zombie virus would behave.
Something about it was very, very different.
It was huge compared to normal viruses. It was substantially larger than any virus that we had seen before.
This is the Goliath of Goliaths among viruses.
So large, it looks more like bacteria than a virus.
We call these kinds of giant viruses mimiviruses because they mimic other creatures like bacteria.
One way the virus mimics bacteria is in the amount of its genetic material. It has 900 genes, 8 times as many as a regular virus.
Viruses are very simple. They don't require a lot of genes to function. But this virus has more genes than necessary. What is it doing with all these extra genes?
We have now found other mimiviruses. 20 years ago, we had no idea that this complex type of virus even existed. We still don't know what all the extra genes do. This type of virus might even be able to generate its own energy, making it closer to bacteria than other viruses.
Because it has so many extra genes, this is a virus that is not acting like a virus.
We can't be sure how the Siberian mimivirus will behave if released. And even if it only attacks amoebas, there could be other large complex viruses buried in the ice. They may not be so safe. Now, as humanity expands beyond Earth to new worlds, will we carry our microcosmos with us into space? Or have we already infected our cosmic neighborhood? Space is no longer the final frontier of the future. We're already exploring the solar system. We've sent probes to the planets and put boots on the moon. Now, NASA plans to land astronauts on Mars by the 2030s.
As a science fiction nerd myself, without even breaking a sweat, I could name 10 movies where people go to another planet and some disease, some alien life form is unleashed on humans and kills us all. I think that has it exactly backwards. If we try to settle on other planets, we have to be really, really careful and really, really think about how we are affecting them.
As we launch more and more missions into space, we risk sending Earth's microcosmos with them, endangering the health of the solar system.
And if we find a planet that actually has its own biosphere, that has life of its own, we need to be very careful about how we introduce our microbes to their microbes, because it could really be catastrophic for them.
NASA does care. Before launching a new probe, a planetary protection team deep cleans every inch.
You try to bake the spacecraft, you try to disinfect things. You build everything and keep everything within a clean room, which has a pressure that blows dust out. Everybody wears what are called bunny suits, so nobody touches anything directly. But then, that's still not enough, because microbes are incredibly hardy.
In the not too distant future, we'll start sending not robot explorers, not probes to Mars, but people. An inherently dirty, mucky organism like myself. You can't sterilize a human, you can't remove all bacteria.
We have to realize that we are bringing the microcosmos with us, and we may change worlds entirely without even noticing it.
Like viruses, we also insist on spreading. We insist on spreading around our world, around our solar system.
There is a great chance that we will cause utter destruction wherever we go.
We think there's about 100 million pieces of microdebris in orbit. That's 100 million invisible bullets waiting for a target.
A collision between two massive objects in low Earth orbit would be catastrophic.
On average, about one piece of space debris falls to Earth every day. Over the years, that amounts to around 6,000 tons of junk coming to Earth. It may not be obvious, but this town plays a special role in this space debris story. Barstow, California. This story begins in 1973 with the launch of Skylab. NASA wanted to put up its first crewed space station. Skylab came to the end of its life in 1974. Its orbit starting to decay, slowly falling back to Earth. By 1979, everyone knew that Skylab was going to re-enter the Earth's atmosphere and crash land. The question was, where?
Skylab, all 78 tons of it, will fall to Earth somewhere.
NASA calculated the odds of 1 in 152 of a piece of debris hitting a person, and 1 in 7 in a piece of debris hitting a large city.
$4 in Los Angeles will get you a Skylab survival kit, complete with predictor module to show you where it will crash, and protective gear in case that's where you are.
Fortunately, we got lucky. Skylab landed near a little town in Western Australia called Esperance.
It shook the entire house, and we realised it was the sonic booms of Skylab breaking up and going over.
Australians began a mass scramble today to find the pieces of Skylab.
So it was all a bit embarrassing. Jimmy Carter had to phone the local mayor and apologize. And as a joke, Esperance fined NASA $400 for littering.
Space is a mess. Unfortunately, it's a mess of our own choosing. Since the dawn of the space age, over 8,000 satellites have been launched, and 5,500 are still in orbit. Many of these objects are going to stay adrift in space for many years, possibly centuries. Take, for example, EnviSat, a satellite that was operated by the European Space Agency until 2012, at which point it died. It's about the size of this school bus. 30 feet long, 16 feet wide. The total satellite weighs 8 tons. While it's sad that EnviSat is no longer functioning, what's truly unfortunate is it broke down in a bad neighborhood. It is currently hurtling through space amidst a swarm of 48 Russian rocket bodies. So just imagine an object this size traveling at 15,000 miles per hour, potentially colliding with another object of similar size. Well, it's going to occur. It's inevitable. The question is not if, it's only a question of when.
Any collision in space is going to be an order of magnitude far more catastrophic than anything we're used to here on the Earth. Low Earth orbit is increasingly like a crazy busy freeway with little Vanguard-sized satellites and huge space platforms, everything in between, all weaving in and out of each other with nobody at the wheel. Sooner or later, there's going to be an epic smash-up. Out there in space, a collision amongst two satellites will affect ultimately all of the others. We're increasingly dependent on our satellites in low Earth orbit. We rely on them when we watch TV, call a cell phone, or use GPS. If they go down, we all suffer. People don't realize how serious this problem is. Space is cluttered. Accidents will happen.
We think there's about 100 million pieces of microdebris in orbit. That's less than about a centimeter in size. That's 100 million invisible bullets waiting for a target. The conditions are getting steadily worse. Each new piece of space junk just intensifies the orbital shooting gallery. If we don't do anything, the real danger is that the trickle of dying satellites becomes a flood.
We're in the operations center for Leo Labs, a commercial company charged with the task of tracking thousands and thousands of satellites and orbital debris, trying to prevent a catastrophic impact in low Earth orbit. Here we're looking at a representation of today's conjunctions, the close approaches between satellites that are actually going on at this moment. And we're seeing things color-coded by impact probability and the miss distance. And things that show up here in red are particularly concerning. But there's a lot of uncertainty in the measurements. The radar data don't tell us exactly where the satellites are. There's a little bit of error by several hundred feet in some cases. All of those factors can play into making it very difficult to project forward where the satellites are going to be at any given time. In 2009, one of the Iridium satellites, Iridium 33, was predicted to pass within a few hundred feet of Cosmos 2251, another satellite up there. Well, at the time of predicted close approach at over 25,000 miles per hour, the two satellites disappeared from tracking. They actually collided. It wasn't a close approach after all. And they disappeared in a cloud of metallic confetti. An incredibly energetic collision. So here we are a decade later, and the debris from that one single collision is still posing a threat to active satellites out there.
The Kessler syndrome. This is what keeps space engineers up at night. It's when a single piece of debris can cause Armageddon in orbit. The Kessler syndrome is a tipping point. It's a moment when space becomes so cluttered that just one collision can have horrific consequences. The fragments from that initial collision expand rapidly. They can hit another satellite, creating more debris. And then those hit another and another. You create an uncontrollable chain reaction which destroys everything in orbit. This idea was first proposed by NASA engineer Donald Kessler in 1978, and he predicted that in 50 years from then, we'd have a critical mass of objects in orbit. he was pretty much right on the money because that would be 2028. And today, there are 8,500 satellites in orbit and millions of pieces of debris. And those numbers are going up almost every day. If we do nothing, a Kessler event is going to happen. And while all the action is going to happen in orbit, there will be significant consequences here on Earth, too. The first thing we'd notice is that our phones would die. All of them. Instantaneous communications and the internet would die as well. And global positioning system satellites are crucial. If GPS goes down, we're literally lost. Cars, airliners, ocean-going shipping containers, they'll be traveling without any guidance. Transactions that underpin modern trade would be fractured. This is disastrous for the global economy. Think about it. A halo of shrapnel around the Earth. That's going to cancel all space flights indefinitely. No weather forecasting, no climate prediction, no space telescopes, no human exploration of other worlds. We'd essentially be back in the 1950s.
Targeted removal of the massive derelicts greatly reduces the risk of future collisions and improves the long-term space safety for all operational satellites. Take, for example, EnviSat, a satellite that was built by the European Space Agency and weighs 8 tons. In the next several years, they're planning on retrieving EnviSat, but it's actually going to be quite an endeavor. You have to rendezvous with the satellite, grapple it, and then bring it into Earth's orbit so it re-enters. As a result, this mission to remove EnviSat isn't going to be on the cheap. It could cost in the order of several $100 million. Luckily, many great minds are working on solutions to this problem. A team in the UK have experimented with a net designed to snag satellites and even a harpoon to skewer debris. There was also a plan to use robotic tentacles to grab satellites and push them back into the atmosphere to burn up. There are other ideas for removing space junk, but they all have their own technical and legal challenges, and none are inexpensive. Since 2000, all satellites are supposed to have deorbit plans. However, what we found is in practice, less than half of the satellites actually do. Now, it's almost standard practice to not deorbit your satellite. We have to change that. There are 8,000 tons of space hardware abandoned in Earth orbit. We need to get started on them soon, and we're running out of time. We must change our behavior now so we don't make the use of space impossible for my grandchildren.
If we don't figure out ways to clean up what we've already put into space, and we don't stop adding more, we really stand to lose the opportunity to get off this planet and explore.
I think a solution's in hand.
Voyager, the most ambitious space mission in history.
The Voyager missions have ventured far beyond where other probes have explored.
They are the most distant emissary representatives of the human species.
Exploring further than any human-made spacecraft has gone before.
5, 4,
August 20th, 1977.
2, 1. We have ignition and we have liftoff.
The mission begins when Voyager 2 blasts off, followed 2 weeks later by its twin, Voyager 1, which will take a shorter and faster route. Their destination, Jupiter, and then Saturn.
When the time comes that mission is actually ready to go to the launch pad, it's a funny mixture of joy and bittersweet loss.
They become like your children. And that launch is like the birth of a baby.
I was standing there watching it climb up into the sky, and we were cheering. We were so happy. Voyager was on its way.
September 1977. Before heading out to the planets, Voyager 1 captures an image to see if everything is working.
That was the first time you could actually see our home and the moon together in the same frame.
It was fantastic. What a great first picture for Voyager.
But Voyager 1 doesn't stick around. It's on a tight schedule. Though funded to just explore the two gas giants, mission planners have a much bigger journey in mind: to send the Voyager spacecraft on a grand tour of the solar system to the outermost planets, Uranus and Neptune, worlds that have never been explored. Both Voyagers reveal an unbelievably dynamic world.
Scientists were able to take a sequence of images of Jupiter that they could put together like a flip book to get a sense of motion, and it was just astounding. Now we can see things moving within the atmosphere of Jupiter in a way that we had no sense of before.
Together, the spacecraft take over 33,000 images of the gas giant. These pictures reshape our understanding of Jupiter, especially its largest moons.
Of all the moons around Jupiter, and there are a lot, Io was the one that shocked everybody.
We got back this very unusual picture. We saw this bright feature on the dark limb of Io, and we wondered, what could it be?
At first they thought that Arc might be another moon behind Io, but the geometry was wrong. There were no moons there. Well, they figured out that these were volcanic plumes.
This is the first time we'd ever seen another volcanically active world anywhere in the solar system, right? It really transformed our ideas, our concept of what a moon could be.
At Jupiter, the Voyagers discover 3 new moons and a ring system invisible from Earth. Not to be outdone, the planet itself has a few surprises. The probes turn to the gas giant's most famous feature, the Great Red Spot.
Jupiter's red spot is a feature that has existed in its atmosphere since we began looking at Jupiter. It's incredible. What it turns out to be is a storm that has lasted centuries.
The Voyagers reveal a maelstrom of gas, swirling counterclockwise between 2 bands of high-speed winds.
The red spot has been kept in a single place because it's sort of sandwiched between these 2 bands of atmosphere.
Like a whirlpool, an eddy, and 2 currents that are moving next to each other. That may have helped promote its stability over all these centuries.
1980, right on schedule, Voyager 1 arrives at the ringed planet. Its sensors probe Saturn's atmosphere and discover it's mainly hydrogen and helium.
Saturn has nearly 100 times the mass of the Earth, but it has so much more volume that when you look at its density, it's actually less dense than water. There's a very old joke in astronomy that if you put Saturn in a bathtub, it would float, but it would leave a ring.
The most striking discovery emerges from the data 9 years after Voyager's flybys, a bizarre cloud formation at the North Pole.
A giant hexagon over the North Pole with sides 9,000 miles long and it's 18,000 miles across. Yeah, that's bizarre.
You don't often think about very stable geometric shapes like a hexagon. That feels like it shouldn't happen, right? You don't get hexagon-shaped clouds on the Earth.
Finally, in 2020, a team solves the mystery. Many cyclones surround a large jet stream at the planet's North Pole. Where the 2 weather systems meet, a hexagon cloud forms. Something we don't see here on Earth.
The trouble with Earth is it has a lot going on. We have oceans, we have mountains, all of that disrupts the atmosphere. On Saturn, there isn't any of that. So you're able to have these very stable airflows It just wouldn't be possible on the Earth. Nature's pretty wonderful.
Next, the Voyagers turned their gaze to Saturn's rings. Their images are game changers. We thought that Saturn had just a handful of wide, flat rings. Voyager's images reveal thousands of separate rings orbiting the planet. But there's an even bigger surprise, an impossible ring.
When the F ring of Saturn, a close-up image appeared on the screen, and instead of being sort of a single ring, it looked like multiple rings that were braided together.
And one of the things that was discovered was 2 satellites that orbit inside and outside of the F ring, Prometheus and Pandora.
When you have 2 little moons sort of co-orbiting with the ring, there's a complex gravitational dance that happens with the inner moon wanting to speed up particles, the outer moon wanting to slow them down, and that interesting gravitational dance is what actually helps confine the ring into the narrow structure that we actually see.
1986. Boosted by a slingshot from Saturn, Voyager 2 arrives at Uranus. After 9 years in space, the probe is now in uncharted territory. We did know a couple things. Uranus has rings and sits on its side.
Unlike most of the other planets, whose spin axes are oriented more or less perpendicular to their orbital plane, Uranus is tipped over on its side. It rolls around the sun like a barrel at times. There are other times where the sun is shining right down the equator. It's very unusual.
In a flyby lasting just 5.5 hours, Voyager 2 discovers 11 new moons and 2 more ghostly rings circling Uranus. But Voyager 2's strangest discovery is the planet's freakish magnetic field. On Earth, that bar magnet lines up close to our planet's spin axis. The Voyager probes found the same at Saturn and Jupiter. But Uranus's magnetosphere is different.
The north and south axis of the magnetic field is tilted by almost 60 degrees relative to the spin axis of Uranus. That's strange.
If you imagine transforming the Earth's magnetic field to be like the Uranus one, you'd have the magnetic North Pole down near Miami someplace. It's way out there in left field.
For now, Voyager 2 is the only spacecraft to ever visit. And what awaits the probe next could be Voyager's greatest discovery yet. 1989, Voyager 2 makes one last flyby. Neptune is the final stop on the planet-hopping tour of the outer solar system. It's a once-in-a-lifetime opportunity to study the blue ice giant up close.
We had these hints from our ground-based telescope that there was activity in the atmosphere. But what its nature was, what was it like? There absolutely was nothing we had to prepare us for what we were going to see.
Voyager 2 spots 4 new rings and 6 more moons. It detects hydrogen, helium, and methane in Neptune's atmosphere. And it records the fastest winds in the solar system, pushing white clouds across the planet at up to 1,500 miles an hour. And at their center, a colossal dark storm. While Voyager 2 leaves the planets behind, its twin, Voyager 1, heads to the edge of the solar system. But not before taking one last snapshot of home, a family portrait.
This idea by Carl Sagan to take this family portrait is just magnificent, and the scientific need for it may have been limited, but the appeal to our sense of beauty, staggering. This family portrait is a series of 60 images put together into a mosaic, and in it you can see the sun and 6 planets: Venus, Earth, Jupiter, Saturn, Uranus, and Neptune.
As we were studying the images, we noticed along one of these sunbeams, there was the Earth, that pale blue dot, which contains every single person We realized just how tiny our planet is and how very special.
February 1990. The cameras powered down for the last time. But this mission isn't over. The Voyager probes are about to reach the edge of the solar system, a region no spacecraft has been to before. In 2012, the probe becomes humankind's first object to leave the solar system, followed in 2018 by Voyager 2.
It's been 50 years since the first satellites poked their way out of the Earth's atmosphere. And now both Voyager spacecraft have poked their heads out of the sun's atmosphere, are outside the solar system and exploring the galaxy.
The Voyagers cross the final frontier and sail the ocean between the stars. They don't see their first discovery, they hear it. This is the sound of interstellar space.
Poetically, I kind of like to think of it as the song the galaxy is singing, welcoming Voyager to interstellar space.
Some of these sounds may even come from distant supernovas. Think about that, a star dying tens of thousands of light years away. And here's an echo of it here.
The sounds of deep space tell us more about our part of the galaxy. Built to last 5 years, Voyager 1 and 2 are now more than 40 years old. Only one final mission remains, perhaps the most important mission, to let the rest of the galaxy know we're here. Strapped to each Voyager is an aluminum case. On the outer side is a map of how to find Earth with directions from different pulsars.
Yeah, the golden discs are literally discs. They actually are records with grooves. You can play them, you can jam out to them. It's got a soundtrack of our species.
The records have tracks by Beethoven, Blind Willie Nelson, and Chuck Berry. The sound of surf, of thunder, of birdsong, and a human heartbeat. So, will aliens ever find the records and give them a spin?
It's possible that they will find it millions or even billions of years in the future, long after we're gone, where there really aren't humans anymore. Or is there even a possibility that when we start traveling to the stars in the far future, we'll find them?
Awaiting discovery, or doomed to drift alone, the Voyager probes have already inspired one civilization, ours.
It seems there are two possible fates for the universe: a big crunch or a big freeze.
If dark energy really is increasing, then the end of the universe is likely to come in a terrifying rush, and it's going to be agonizing.
So when we wind the clock back 13.8 billion years, we find there was a time when everything was contracted into a single point. The time of the Big Bang, the very beginning of the universe. And if it had a beginning, will it have an end? And what might that end look like? Working this out is one of the greatest challenges of cosmology.
The key concept here is entropy, the tendency of order to transform into disorder. It's a law of nature. It's built into the very fabric of our universe. Take my cup of coffee here. Its energy is concentrated because it's hot. But as soon as I pour it, that heat starts escaping into the world around it, dissipating in the form of steam. That's entropy at work. It takes the energy and spreads it out, equalizing the temperature, moving things from order to disorder. My coffee will never spontaneously get hot ever again. Can't stand cold coffee. That's why things, when left alone, will crumble and decay. They're tending towards disorder. Entropy is what gives us our perception of time. It distinguishes the past from the future. This process is irreversible. It only happens in one direction. There's only one way to organize these pictures that makes any sense. We know that this one has to come first. The cup is whole, the coffee is hot inside. It's orderly. This one has to come afterwards. It's disorderly. The cup is broken, the coffee is scattered across the ground. Order becomes disorder. That's the fundamental law for everything, whether it's coffee cups or the universe.
It may seem that entropy has us on an inevitable path to a cold and lonely ending. But perhaps that's not the only possible outcome, because there's another fundamental force at work. One as universal as entropy, gravity. And it does far more than keep our feet stuck to the ground. Its irresistible pull affects all things in the universe. Gravity could bring about a very different fate for the cosmos. If you look for Cassiopeia's W in the night sky, and you take the bottom right and you go down a bit, that fuzzy patch of sky, that's the Andromeda Galaxy. Like the Milky Way, Andromeda is a spiral galaxy, roughly 2.5 million light-years away. But that's not a constant, and with every passing second, the gap is shrinking. You see, unlike most distant galaxies, Andromeda isn't traveling away from us. Instead, it is hurtling towards us at a staggering 224,000 miles per hour. That's 100 times faster than a speeding bullet. Which means in 4 billion years or so, Andromeda and the Milky Way will collide and form a new combined galaxy. We've even already named it, Milkomeda. This isn't all down to chance or a case of bad cosmic navigation. The force of gravity is pulling the two galaxies together. Some of the stars in the night sky didn't start their lives in the Milky Way at all. It's thought that our galaxy has already consumed 15 other, smaller galaxies, adding their stars to our own. And gravity is causing the same chaos almost everywhere we look in the universe. If gravity is strong enough, then the universe wouldn't keep expanding forever. Instead, it could collapse.
As the universe shrinks, gas and dust are brought together, and a new generation of stars ignites. At first, it would be fantastic. The skies would be ablaze with new stars, plenty of energy, perhaps a flourishing of life. But the good times would very quickly come to an end. As gas and dust get ever more concentrated, the stars get bigger and brighter until eventually they start exploding as supernova. This would be a spectacular fireworks display, but it would also fill space with radiation and shockwaves, so things would really be getting worse. As time goes on, the universe shrinks at an ever-increasing rate. It becomes unstoppable. That means all the material, all the heat and energy, even the stuff created in the Big Bang, is crashing down on you as a kind of roiling wave of ever-increasing intensity. This wave is so intense, it can tear planets apart, destroy stars, and will lead to the extinction of all life. The universe carries on shrinking like this until it's infinitely dense, infinitely small, and infinitely hot, just like the Big Bang all of those billions of years ago. This is the end that gravity brings. Not a big freeze, but a big crunch.
So it seems there are two possible fates for the universe. a big crunch or a big freeze. And it all comes down to this competition between gravity and entropy. If entropy wins, the universe expands forever and eventually freezes to death. But if gravity wins, the universe eventually is sucked back in on itself and ends in a big crunch. You might think it's impossible to answer this question, but it turns out that we can. And it comes down to a different question. How much stuff is there in the universe? Gravity is the attraction of anything that has mass, and the more mass you have, the more gravity there is, and therefore the harder everything pulls on everything else. And thanks to Einstein and his theory of relativity, we can work out exactly how much mass there needs to be in our universe for gravity to eventually win and spool everything back together again, kind of like when an angler pulls in a fish. And we've even given this a name, critical density. It turns out that the critical density for our universe is equivalent to 6 hydrogen atoms in a cubic meter. 6 hydrogen atoms in every cubic meter of the universe, that's nearly nothing. To give you a sense as to how little mass that is, that would be equivalent to if these 6 grains of sand were the only mass in a volume the size of the Earth. That really is a very small amount of mass. I mean, look around you. There's so much stuff in the universe. Clearly, the universe must have more than just 6 hydrogen atoms per cubic meter. And therefore, clearly, we must be in the situation where our universe will be above the critical density, and therefore, eventually, gravity will win, and our universe will end in a big crunch. But maybe not. Space is called space for a very good reason.
If the universe is expanding, then shouldn't it be slowing down based on all the gravity of everything in the universe attracting everything else? As the universe expands, we have this picture of galaxy after galaxy after galaxy. All the distances between all the galaxies gets bigger and bigger, and the galaxies all separate from each other. What we're trying to do is we're trying to measure how much this expansion is slowing down. If you're a little bit above this critical density, as we call it, that means it'll actually slow to a halt and then turn around and start to collapse again. If we find that the universe has less than that critical density, then it will always be expanding. It'll never come to a halt. But it'll expand slower and slower. Either case, the universe would have been expected to be slowing down because gravity will slow the expansion. And that's what we were looking for. And then the data started coming in, and we found that the universe wasn't slowing down at all. It was actually taking off faster and faster. All the galaxies were blasting away from each other at an ever-increasing rate. Of course, that was as surprising as if you had just thrown an apple in the air and instead of falling back down, it had just taken off. When we finally believed the results, what it looked like is that we live in a universe that was, in fact, slowing in the past. And that happened for about the first half of the life of the universe. But about 7 billion years ago, it stopped slowing down and it started to speed up. And it's been speeding up ever since. Then the question was, well, what's causing it? We knew there was a possibility that there was a new energy that was spread throughout all of space that was causing this acceleration. But we don't know what it is. So to represent this ignorance, this mystery, as scientists, we started calling it dark energy. And the dark isn't the color, the dark is the ignorance. It's the fact that it's mysterious. We don't know what it is that this energy consists of that makes the universe accelerate. And this dark energy has a dramatic effect on the expansion of the universe. It is, in principle, powerful enough to tear the universe apart.
Imagine our species finds a way to survive to the end days of the universe. But after all that, it turns out there's one thing we can't avoid: dark energy. If dark energy really is increasing, then the end of the universe is likely to come in a terrifying rush, and it's going to be agonizing. Some recent theoretical models predict that within a few billion years, the expansion of the universe becomes exponential, reaching an astonishing rate. Space expands so violently that our galaxy comes apart at the seams, flinging stars away from each other. Even solar systems are powerless in the face of this onslaught. Our own star will be torn away from us in an instant. Our moon follows. Dark energy permeates all of space, including the infinitesimal gaps between and within atoms and molecules. The expansion of space can become so extreme that even that space expands, tearing apart atoms and matter. I can only imagine what it would be like to be torn apart atom by atom. The insatiable drive of dark energy starts to stress the very fabric of space and time itself, until in an instant, everything that ever was or ever will be torn asunder. This is the way the universe ends, in a big rip.
There's one epic battle happening above our heads, between two forces that are flexing their muscles right across the universe. Expansion is fighting to push everything apart, while gravity pulls everything together.
Dark energy. It could be something that's constant. Everywhere you go, there's this energy of empty space, and it stays the same forever. You might think that means that there's no way that the universe is going to slow down now and come to a halt and collapse. So there's no way we'll get a big crunch. But since we don't yet know whether or not this is a varying dark energy, all bets are off. It's possible that the dark energy will change its behavior over time and maybe lead to some future slowing and a future big crunch.
Our neighbor Mars fascinates us. Working together, they dig into Mars's past to answer the ultimate question: did Mars once have life? February 2021. The newest robot investigator speeds towards Mars, the most advanced rover NASA has ever sent to another world. This is Perseverance.
The goal of the Perseverance mission is to look for signs of past life on Mars.
First, it must navigate safely to the surface of the planet. Perseverance enters Mars's thin atmosphere at close to 12,500 miles an hour. And deploys a parachute.
Navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity.
Perseverance activates its jetpack. Retro rockets slow the lander's descent to a crawl. Then, 66 feet above the surface, the Sky Crane uses cables to gently lower the rover to the ground.
Tango Delta. Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Curiosity searches for evidence of calmer, more permanent water in Mars's past. Investigating layers of rock at the base of Mount Sharp, a 3-mile-high mountain in the middle of the crater. and discovers rounded pebbles like those we find on Earth.
When you see a rounded pebble on Earth, you know that that got rounded in a river channel. Some of them used to be angular, but their angles all got knocked off by being rolled and rounded and moved by water. So we're very excited when we see rounded pebbles on Mars.
The rock layers and rounded pebbles tell us that over 3 billion years ago, Gale Crater was a lake fed by rivers. While robot team members Curiosity and Perseverance work the Martian surface, 8 probes orbit the planet, searching for clues about Mars's ancient wet history. Leading the pack is MAVEN. Its mission? To solve the mystery of Mars's lost atmosphere.
Today, the atmosphere of Mars is incredibly thin. It's only about 1% the atmospheric pressure. When you see things like river channels that probably took millions of years to carve, that gives you an idea that the atmosphere was once very, very different. It had to be thick to allow liquid water to exist on the surface.
MAVEN's data reveals that Mars has lost 65% of the argon from its atmosphere, and the solar wind continues to bombard the planet.
The atmosphere of Mars is being stripped away by solar radiation by 1/4 pound every second.
This rate of atmospheric loss leads to one conclusion. The solar wind robbed Mars of its once thick atmosphere, and with it, the planet's water.
So why is it that Earth's atmosphere is still mostly there, whereas Mars's has been stripped away?
Earth has a protector, a magnetic field that shields our atmosphere from the ravages of the solar wind. Dating the magnetized rocks reveals that Mars had an active magnetic field for almost 1 billion years.
This means that the atmosphere of Mars was protected for those billion years. And if the atmosphere was protected, the liquid water was protected. And if that liquid water was a home for life, then that life was protected.
But something happened to bring Mars's force field down. Now, InSight probes the planet's interior. Its mission? To discover if the secret of the planet's lost magnetic field lies beneath the Martian surface. 2021. InSight listens for seismic vibrations called Marsquakes as they travel through the planet's interior. The magnitude 3.1 and 3.3 quakes came from Cerberus Fossae, a series of trenches that stretch for 750 miles across the Martian surface. Some fissures cut through impact craters that are only a few million years old. This means Cerberus Fossae must be younger. InSight's new and improved layout of Mars reveals a 969-mile deep mantle surrounding a metal-rich core.
We have always thought that the core of Mars was long since solidified and wasn't warm at all. And InSight is now showing us that actually part of the core is probably still molten, which is shocking. Mars seems to have a bit more sulfur, at least in the surface, than Earth does. If we extend that composition to the core and add more sulfur to the iron-nickel core, that would actually reduce its melting temperature, making it possible for this core to be molten today.
We thought that Mars lost its magnetic field when the core cooled and solidified. A molten core changes everything. Over time, as Mars lost heat and cooled down, its core stayed molten thanks to the sulfur. But with less heat, there was not enough energy to power the churning convection of liquid metal that creates an electric current.
The convection in that core would have slowed down to the point where no magnetic field would be generated.
3.7 billion years ago, Mars's magnetic shield dies. The solar wind's relentless attack strips the planet of its atmosphere. As the atmosphere disappears, water on the surface gradually boils away. Where is Mars's water hiding? Some scientists think it could be stashed away in the Martian rocks.
When we look at a rock, we often think this is a really dry thing. There's no water in there. But in fact, there's often a lot of water in rocks, and it's because it's bound up in minerals.
Researchers estimate that as much as 99% of Mars's water could be locked away below the surface. And Mars hides water in other ways too. Enter the European Space Agency's orbiter, Mars Express. Probing 1 mile beneath the Martian South Pole, it finds a secret store of water. We still aren't 100% sure that the lakes are completely liquid. Some scientists think they could be lakes of frozen clay. Until we have a rover that can explore beneath the poles, we won't know for sure. And so the search continues, and Curiosity uses another piece of equipment to sniff out traces of past Martian life. Like a robotic bloodhound, it sniffs the vaporized dirt and picks up the faint smell of a rare molecular compound.
What Curiosity discovered was a compound called thiophene. This is interesting because, at least on Earth, thiophene is often found in fossil material, in coal, in oil, as well as stromatolites or microfossils of ancient life in the fossil record. So maybe this thiophene we've now discovered on Mars is some trace chemical fossil of ancient Martian life. Or possibly it was produced by non-biological processes.
Curiosity is knocking on the door of finding the evidence for life on Mars. We haven't found life, but we've found the interesting bits that are pieces of the puzzle, the organic puzzle of life on Mars. And so it's getting us to that ultimate question, is there or was there ever life on the planet?
In Gale Crater, Curiosity detects a huge surge of methane gas.
The methane we've detected in the atmosphere of Mars is potentially very, very exciting. Most of the methane in our own air, in Earth's atmosphere, is biogenic. It was released by living organisms.
Curiosity's result is exciting because we know that this can't be ancient methane.
Methane is really interesting because it has a short residency time in an atmosphere, which means it breaks down very quickly. Whatever is making methane in Gale Crater is doing it right now.
Maybe this Martian methane is the first trace we found of Martian life. Microorganisms living deep underground. Or maybe that methane is not biological, but geological. It's methane that's been given off by volcanic processes in the past. The frustration is we can't quite tell the difference between the two just yet.
There's something in or on Mars that is adding oxygen to the Martian atmosphere during the spring and summer and then taking it away during the fall and winter. There is something that is actively controlling the amount of oxygen in the Martian atmosphere. What is that?
The atmospheric changes in oxygen and methane are a fascinating puzzle and a tantalizing hint of life.
Life on Mars explaining these changes in methane and oxygen would be incredibly interesting.
The army of robotic explorers continues to rewrite the story of Mars, discovering a once warm, wet world with the potential for life. Now, a new generation of robots, led by Perseverance, will dig deeper into the red planet's troubled past and its frozen present, and maybe hit the mother lode, life itself.